So today we're looking at section 1.1, which is an overview of statistics. So you may not realize it, but every day you hear statistical information. We hear it all the time. Watch television for half an hour and you'll see ads for different products, and they'll make statistical claims. Things like 4 out of 5 dentists surveyed agree that this particular gum prevents tooth decay, or 0.6% of children born in the U.S. develop autism, or 42% of registered voters support Prop 174. Those are all statistical claims. We're constantly bombarded with statistical information. So whenever we hear claims like that, there's got to be some mechanism in the background that allows those manufacturers or those people that are creating the ads to make those claims. So anytime you hear statements like these, there must be some data lurking in the background. So we need to give a formal definition to what data is. So data is information gathered by counts, observations, responses, or measurements. Information gathered by counts, observations, responses, or measurements. So at its foundation, data is information. It could be numerical information, it could be descriptive information, but it is some sort of information that we're gathering. And people have done this for a long, long time. Data has been systematically gathered for thousands of years, and we have evidence to support that claim. So, for instance, statistical counts are found on ancient Egyptian papyri. So, when they unearth a tomb in Egypt and they go in and investigate what's inside, oftentimes they find these what are called canopic jars. Some canopic jars contain the remains of the people. For instance, when they mummified an individual, they took out the bodily organs and they stored them in jars. And then they left the rest of the corpse mummified, either in some kind of sarcophagus or in a coffin of some sort. But other canopic jars contained scrolls that were written on papyrus. Papyrus was the basically paper that the Egyptians had. They pressed reeds from the Nile River into a pulp and then dried the pulp, and then they could write on that to keep records. And when you would see those papyri, you would find all kinds of stuff on them. A lot of people think, oh, they find these scrolls and there are these stories of the great pharaohs of Egypt, and they tell of all these battles and conquests, and there's a few of them that do, but more of them are very boring. You'll find things like farmland production records on these papyri. You'll also find grain storage records and military food allotment. How much food are they giving the troops? So if you think about these three things, and these three things actually make up the majority of what you find on ancient papyrus when you unearth a tomb, why would these things matter? Why would a pharaoh want these records buried with them at the time of their death? And the answer is kind of simple. These are the ways that a leader shows how successful they were in the ancient world. In today's world, there are places where people are starving. In the ancient world, it happened much more frequently. So, if you want to tell the future about your skill as a pharaoh, about how good you were as a leader, then one of the things that you want to tell everybody is how well you kept your people fed. Here is how much food we produced when I was the pharaoh. Here's how much extra we had in case of famine. And here's how much food I gave to my troops to keep them happy. Right? Success in the ancient world was about being able to feed your people. So these are the kinds of records that they would hold dear to themselves. The conquests and the land that they acquired were also important, but these things were measures of success. You'll also find statistical counts in the Bible. Now, I'm not saying that you should believe in the Bible and what it says as far as religion is concerned, but it is a book that's been around for thousands of years, so it's a historical document. And in that historical document, there is statistical information that is collected. So, one of the most famous stories in the Bible is the story of the birth of Jesus. And it starts off with Joseph and Mary traveling to Bethlehem. And the reason that they were traveling to Bethlehem is because the Roman leader at the time, Caesar Augustus, had ordered a census. And what a census is it's a counting. It's where you go and you count the people. So, question, why would a leader want to count their people? Think about that for a second. Why would a leader want to count their people? And try not to be influenced by your thoughts about leaders today. Think about leaders in the ancient world. Why would they want to count people? What is their motivation? Oftentimes, people will ascribe to leaders very benevolent motives, like, oh, they want to know how many people they have so they can help the people out. Yeah, that's not what it was. In the ancient world, if they wanted to know you existed, it's because they wanted to tax you. The Roman Empire was all about taxation. So, because the Roman Empire was in control of Israel, modern day Israel at that time, they wanted to know how many citizens there were, because once they knew how many citizens there were, they would know how many people they had to tax, which allowed them to know how much money they could expect to come in so they could plan future military campaigns, so they could plan future expansions of the empire. They also wanted to know how many men of military service age there were, so that if they needed to press individuals into service, they could do that. But those kinds of counts are found in the Bible. There are other instances of statistics in the Bible, but that's probably the most famous one. Statistical counts are found in the United States Constitution. The United States Constitution requires that every 10 years a census is performed. So in the year 2000, in the year 2010, in 2020, in 2030, census is going to be required. And that's just a count of the people. It's gotten more complex over time. And the census is an incredibly difficult thing to do because pretty much as soon as you've done it, it's wrong. If you're trying to count all of the people in the United States, and there's somewhere near 330 million people in the United States, your count is going to be inaccurate. You're not going to get a good count because it takes time to count 330 million people. Once you've counted a household, let's say there are 5 individuals living in the house, a mother, a father, and 2 children, and a grandmother, say, who live in a house together. And then the Census Bureau comes by and they count those 5 people. And then 3 days later, there's a baby born in the house. That baby wasn't counted in the census because that child, according to the government, didn't exist yet. So once that child is born, the census is now inaccurate, right? If you could count everybody in a day and get it all right, the next day it's going to be wrong because people are going to be born and people are going to die, and the births and deaths are not necessarily equal to one another. So you are constantly having a shifting number. There's no way to accurately take a census with a really large population. That's a problem. So we tend to use samples more often than we use population data because getting a hold of an entire population, especially when the population is large, is very difficult to do. So before we can do anything else, we have to ask ourselves one basic question. What is statistics? So we'll define the concept of statistics. Statistics is the science of collecting, organizing, analyzing, and interpreting data, the science of collecting, organizing, analyzing, and interpreting data. Now, there's more to it than that, because we need a motivation. Why would we do this? And the reason we do that is in order to make decisions. So statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. One of the things that we'll learn in this class is how to classify data. And data can be classified in several different manners. One of the first ways that we learn how to classify data is by looking at the difference between data that's collected from a population and data that comes from a sample. So let's look at populations versus samples. A population is a collection of all data values that are of interest. Collection of all data values that are of interest. A sample is a subset of a population. So a subset means we're taking some of the values, not all. Populations refer to all of the data values. Subsets refer to some of the data values. And so we have a note. A population does not have to consist of people or animals. A population does not have to consist of people or animals. A lot of times people hear the word population, they automatically think people or animals. But your population could be a collection of tongue depressors. And you might be interested in the number of warped tongue depressors that are produced by a manufacturer. So you look at the population of all tongue depressors that are manufactured in a day. That would be a population. And then you try to find how many are warped from that population. There's no animal, there's no people involved in that. It's a population of things. So try not to misconceive the fact that populations are living individuals. They are not. They can be, but they don't have to be living individuals. So let's take a look at an example. The daily high temperature in Madeira for every day in 2010 was recorded by the National Weather Service. 42 of those temperatures were chosen at random. So we have a couple questions. First, identify the population. Then identify the sample. And what does the data set consist of? Okay, so let's think about those things. When you're given a series of questions, it's not always necessary to answer those questions in the order in which they appear. So for instance, I think it's much easier to answer the last question first here. So that's what I'm going to do. The last question is, what does the data set consist of? Well, this data set is made up of temperature values. So we've got temperature values. What's the population? We're talking about daily high temperature values in Madeira in the year 2010. So that's what my population consists of, the 365 daily high temperature values in Madeira for 2010. Whenever we're describing a population or describing a sample, we always try to be as specific as possible. So we don't just say the daily high temperature values. We add in all the information we possibly can. We knew how many there were because there were 365 days in the year 2010. We knew that they were daily high temperature values in Madeira for 2010. So all of that descriptive information should be part of your description of the population. Always be as specific as possible. And question 2 was to identify the sample. Well, what the sample is it's the 42 randomly chosen daily high temperature values, right? So we had 365 daily high temperature values in Madeira in 2010. The sample consists of the 42 randomly chosen high temperature values from that group. So sometimes we'd like to be able to see a picture of what's happening. And in statistics, a lot of times that picture is called a Venn diagram. What a Venn diagram is it's a visual depiction of a population and its subset or subsets. And it's not necessarily to scale. What that means is we'll have a figure drawn that represents a set. The size of that figure doesn't necessarily relate to the size of the subset. So we might draw all of our figures the same size, but some of those subsets might be larger or smaller than others. So the size of the figure you draw is not relative to the size of the sample. Bigger figures don't mean bigger samples. So let's talk about how to create a Venn diagram. The process. First, we're going to draw a box and label it with the population information. So we'll have a rectangle or a square, and that will be labeled with the population information. That rectangle or square represents your universe. What are you looking at? What is your entire population? Next thing you'll do is specify the size of the population, if you know that. We use a capital N for the size of the population. Now, it's not always possible to know the size of the population. For instance, if we were talking about the population of the United States, it's around 330 million, but we don't know the exact number. And the exact number right now might not be the exact number half an hour from now, because babies are born and people pass away. So that number is in constant flux. But if we can label the size of the population, we definitely do. Then, inside of that box that you've drawn, that rectangle or square, you're going to draw a closed shape that represents each subset. So each sample is going to be depicted by a closed shape. Most of the time we use a circle, but other times we can use some other shape. The only rule about the shape is it must be a closed figure, so it can't be open. It has to complete itself. It's got to attach end to end, and there's no little loops within the figure. That's why we do circles. Circles are just easier. And then you allow those circles or other shapes to overlap if it's possible that those subsets have a common element in them. So if they share any of the same values, then they would overlap. So for instance, if you had a sample of people who had brown eyes, and you had a sample of people who had brown hair, then those two shapes for those samples should overlap, because there are people who have both brown hair and brown eyes. So those two shapes should overlap. They shouldn't completely overlap, because there's people with brown hair that have green eyes, or people with brown hair that have blue eyes. And there's people with brown eyes that have blonde hair. And there's people with brown eyes that have red hair. So you can't completely overlap them, but they would have to overlap because they do share common values. Then you're going to label each subset with its size whenever that's possible. Just like it's not always possible to know the size of a population, it's also not always possible to know the size of a sample. So let's take a look at an example. We want to try to draw the Venn diagram for the previous example we talked about that dealt with daily high temperature in Madeira for every day in 2010. So we'll first draw our box and label it with the population information. These represent the 2010 daily high temps in Madeira. We put the size of our population, n equals 365. Now you can put it in that upper right-hand corner. You could also put it in the lower right-hand corner, as long as that information is there. Then we're going to draw a shape. Here's my shape. That shape represents the sample of randomly chosen daily high temps in Madeira. And we know the size of that sample. That sample was size 42. So this is a very simple Venn diagram. We didn't have multiple subsets, so there's no overlapping here. And this is your answer for that example. Let's see if we can interpret a Venn diagram. So something that's a little bit more complicated. So, consider the Venn diagram pictured below. Can you, as completely as possible, describe the individual marked by the X? So let's take a look at our Venn diagram. Our Venn diagram is about fall 2020 full-time Madera Community College students. And then we have three samples, three subsets of that population. We have a subset for honor students, we have a subset for car owners, and a subset for students receiving financial aid. And there's an X drawn in one of those overlapping spots. So think about this for a second. Can you describe that individual marked by the X as completely as possible? So pause the video, think about that, try to write down a description, and when you're ready to see what it should be, press play. Okay, so people will often make the mistake of not including certain information. For instance, when they're describing the individual, they forget the information in the population description. That individual X is part of that population. And far too often, people will try to describe what the student is, and they leave out what the student is not. Because if we're describing as completely as possible, then we need to not only say what features this student has, but also what features they don't have. What do I mean by that? Well, here's our description. Student X is full-time at Madera Community College in fall 2020, is an honor student, receives financial aid, but does not own a car. How do we know they don't own a car? They fall outside the circle of car owners. You can see the circle of car owners, and that X is outside of that. So that means that this student is not a car owner. But they are an honor student because they're inside the honor student circle. They are a student who receives financial aid, and they are a full-time Madera Community College student in fall 2020 because they're in the population. So put the information about the samples, about the subsets, also put the information about the population, but don't forget to include information about what the student is not. In this case, that student is not a car owner. Okay, so here's another practice problem for you. 33 of the Fresno Unified School District school administrators were surveyed about the number of hours they worked each week. The average number of hours worked each week was found to be 49. So we'll ask a series of questions. First, identify the population. Then, identify the sample. And third, what does the data set consist of? So give yourself a little bit of time to work on this problem. Press pause on the video. And when you're ready to see the answer, press play. Okay. So, remember, you can answer the questions in any order. And I like the last question first. What does the data set consist of? The data set is made up of hours worked by Fresno Unified School District administrators. Right? It's not about the administrators themselves, it's about the hours they work, because that's what we're compiling. That's the data we're requesting. We call up the principals, the vice principals, we say, hey, how many hours do you work? So that's the data that we're collecting. Then question 1, identify the population. So the population is all the Fresno Unified School District administrators. Right, so that's who we're questioning. And then the sample is the 33 Fresno Unified School District administrators that were surveyed. Right, so the population is several thousand in Fresno Unified School District. When you look at all the different schools, the principals, the vice principals, people that work in the district office, all the different types of administrators, there's more than just principals and vice principals. So you get to more than 1,000 administrators in Fresno Unified School District, but we only surveyed 33 of them. So that sample consists of the set of 33 Fresno Unified School District administrators that were surveyed. So time for a couple more definitions. The first definition is the definition of a parameter. What a parameter is it's a numerical description of a population characteristic. When we talk about parameters, we often also talk about statistics. So a statistic is also a numerical description, but it's a numerical description of a sample characteristic. So this is an easy distinction to remember. The definitions are very similar, right? Parameters are numerical descriptions of population characteristics. Statistics are numerical descriptions of sample characteristics. So how do we keep them straight? And it's letter association. Parameters, the word parameter starts with a P. Population starts with a P. Statistic starts with an S. Sample starts with an S. So P with P and S with S. Parameters describe populations. Statistics describe samples. So it's pretty easy to keep straight just by using the letters and the words. So let's go ahead and look at an example. Determine whether the following are parameters or statistics. 1. The average annual salary for the top 35 of a company's 1,200 accountants is $67,000. And 2. In a recent year, the interest category for 12% of all new magazines was sports. So let's go ahead and start by looking at the first one. The average annual salary for the top 35 of a company's 1,200 accountants is $67,000. The key here is to read the phrase, the top 35 of a company's 1,200 accountants. That means we're not dealing with the population. We're only dealing with a portion of them, only 35 out of 1,200. So that makes this a sample statistic, because it only deals with a portion of the entire population of accountants for this company. For the second one, in a recent year, the interest category for 12% of all new magazines was sports. The key words that we're looking for here is the word all. When we see the word all, that tells us we're talking about a population parameter, because it refers to a value that represents all new magazines. So when you're dealing with some, you're talking about a sample. When you're dealing with all, you're talking about a population. So there are two big branches of statistics that we'll talk about. And those branches are descriptive statistics and inferential statistics. So descriptive statistics is the branch of statistics involving the organization, summarization, and display of data. And inferential statistics is the branch of statistics involving the use of a sample to draw conclusions about a population. So the basic difference between these two branches of statistics is that the descriptive side of statistics is very mathematical and very analytical. It's all the number crunching that we do to obtain our data. What inferential statistics is it's a little bit fuzzier. It's less objective and more subjective. It's where we're taking the data that we compiled in the descriptive side and then using it to make decisions. We're trying to make predictions about the way we think things will happen based on that data, and then make decisions based on those predictions. So that's what inferential statistics is it's where we're actually going through that decision-making process based on the data. And the descriptive statistics is where we're actually compiling the data. So that brings us to an end of section 1.1. Please make sure you look at the Pearson website to get your homework, and have a great day.